Good morning, class. Today we are focusing on the tangent graph and what that looks like. What we need to do to start out with is type all of these numbers into your calculator. Tangent of negative 90 degrees, tangent of negative 67.5, and go on down through the list just like we did last class period with sine and cosine. So go ahead and start that now and hit pause on this video until you have that done. Okay, now that you have that done, these are the points that you should have found in your calculator rounded to the nearest tenth. Before we plot these points, there's a new vocabulary term that I need you to be familiar with, and that is an asymptote. An asymptote is a line that a graph approaches and gets closer to but never intersects. At any point during this video, just hit pause if you need more time to write anything down as I go through this. So as we are...
Joseph Marr, please report to the front office. Joseph Marr to the front office, please.
As we are going through this graph, we have several times where we have asymptotes. And the tangent asymptotes occur at negative 90 degrees, (90°), 270 degrees, and negative 270 degrees. The tangent graph is a little bit unique compared to sine and cosine, as their periods were 360 degrees. The tangent graph actually only takes 180 degrees for the graph to start repeating itself. And so that's when you'll see the 270 and negative 270. So asymptotes. Asymptotes are going to be when you get an undefined in your table. So what we need to go ahead and do now is draw in a dashed line at negative 90 and 90 degrees. These dashed lines are going to be our asymptotes, meaning the graph is never going to touch them. And here is the first tangent graph. So what we're going to do is we're going to take our points here. So at negative 90, we are undefined. At negative 67.5 degrees, we are down here at about 2.4. We're crossing at 45 at negative 1, and 0, 0, 1, 1. And over here at that 67.5, again, we are up at 2.4. The same thing is going to happen as we go on the other side of the 90 degrees. So we're back down here at negative 2.4, negative 1, 180, 1, and then up here at this 2.4. The 0.4s, the negative 0.4s, those really do kind of help you see the curve that I'm going to draw in here again. And if we would have kept going past 180 degrees, we would see, if you took the tangent of 270 degrees, you would see that we have another asymptote occurring over here. And excuse my jerkiness here as I'm trying to graph these. Okay, so the curve that we're going to have, the parent graph for tangent, is going to kind of curve up towards this asymptote. I missed that point a little bit. And curve down towards this asymptote. Okay, and then we're going to curve up. And we're going to curve down. This might look kind of familiar to you, like the cubic function that we had in the pit and the pendulum unit. And the same thing would occur over here. We'd have an asymptote at 270 degrees. And really the parent points that I focus on at negative 180, we're at 0, 0, 1, 1, negative 1, 1. And I really just kind of curve it up towards the asymptote like this and down towards the asymptote like this. And that really fits the parent graph. Okay, so key points here. Maximum, we're never going to have one. Okay, we're infinitely approaching up towards these asymptotes. Minimums, we're not going to have one. We're continually approaching down towards these asymptotes. X-intercepts, those key ones that you need to know. We're going to cross the x-axis at 0, 0, negative 180, 0, and 180, 0. The only time that we will ever, and those will continue, the x-intercepts, will continue because this can repeat left and right forever. The y-intercept is only ever going to be 0, 0. Okay, so now we are ready to start looking at transformations. So example 2. The very first thing that we want to do is sketch our parent graph just like you did for sine and cosine. Okay, so go ahead and hit pause right now and get your parent graph put in with dotted lines like this. Okay, now that you have your tangent parent graph sketched out, we need to pay attention to our transformations. So just like before, we know that this multiplying by 2 out front is a vertical stretch of 2. So we're going to take those parent points that we know about. So 0 times 2 is 0. 1 times 2 is 2. And negative 1 times 2 is 2. The asymptotes are going to stay in the same spot, and we're going to be a little bit taller and skinnier curves. Same thing is happening here, 0, 0, negative 1 turns into 2, 1 turns into 2, and we are taller and skinnier. And the same over here. Okay, so now on example 3, we're on the back, tangent of theta plus 45 degrees. Your note guide does have an X right here, and your note guide is still calling this example 2. Sorry for that confusion. But again, what are we going to start with? We're going to start with getting our parent graph put on here. So again, hit pause while you practice tracing out that parent graph. Okay, so now that your parent graph is on your graph here, what does 45 degrees inside the parentheses do? Well, as you know, 45 inside, because this is plus, we are going to shift left 45 degrees. Now that is paying attention on the x-axis. So when we shift left and right, the asymptotes actually do move, and every tick mark here is 45 degrees. So that's what I'm going to start with first. I'm going to move all of my asymptotes to the left, 45 degrees. and then just move every point 45 degrees. So now I'm here, here, and here, up, down, and you know, sometimes with my slate, my graphs aren't always perfect. And this is looking very busy with the old asymptotes and the new ones, but everything in black would be the transformation graph. Okay, looking at example 3 on your note guide, we have y equals tangent of theta minus 2. So this minus 2 is outside of the parentheses, and so this minus 2 is going to look like we are, or this graph, its transformation is going to shift down 2. So the nice thing here, again, hit pause if you do not have your parent graphs drawn on here. And again, the nice thing here is that the asymptotes are going to stay in the same place. So we're going to take everything down 2. So 0 turns into -2, moving down 2 on each spot. So then we're going to curve back up towards those original asymptotes. Oh, I didn't quite go down 2, I went down 1. And the last one. Okay. And the last example. The last example here listed on your note guide is number 4. We have times 4 out front. Multiplication out front is a vertical stretch of 4. And this negative side inside, negative theta or negative x, this is a reflection over the y-axis. And again, hit pause if you do not have your parent graph sketched out. Okay, so now that you have your parent graph sketched out, with a vertical stretch and a reflection, our asymptotes are going to stay the same. And so here at 0, 0, that's going to stay the same when I reflect over the y-axis. So what we need to do is we need to do all of our reflections and then do the stretch, okay? So the center one, let's start here, because this one over the y-axis is going to come over 0, 0 is going to stay the same. But this point here, this point that is at 1, 1, now is going to be over here for the reflect over the y-axis, but then it's going to stretch by 4. So 1 is going to turn into 4. So this one's going to be real, like a tall and skinny. So then on the left side of the y-axis, we need to move over to the right for that reflect over the y-axis, and then it's going to stretch down to 4. And so then this curve looks like this. Okay, so let's, and then over here, once everything on this point really is going to shift all the way over here. So at negative, this negative side over here, sorry, excuse me, is going to shift over. So if you want to count the ordered pairs, your 1, 2, 3 points on the left side of the y-axis, we need to be 1, 2, 3. So we're over here, 1, 2, 3, 4 points away from the y-axis, 1, 2, 3, 4. And that's one way to count it out. And you know that it's going to be the exact same in the middle. So we're going to just shift up, or not, and then come down like this. And again, sorry, I'm not hitting my points perfectly. Oh, this is the point where you'd be like, Mrs. Wall, you forgot to stretch by 4. There we go. I'm glad I caught that. Okay, so we're at 0, 0, and then that 1 point that was going to be here at 1, 1. We need to go up to 4 and down to 4. Gives me a chance to draw a better graph. There we go. And back down. And then over here, up. And won't forget the stretch of 4 this time. Okay, so hopefully you're able to follow through just fine on these tangent notes. Send me a message or an email if you have any trouble, and I will see you next week.